All right. Good evening. Hope you are fine. Um, quick. Once again, fearfully ugly here. Some people don't like to call me by fearfully ugly, so my real name is actually Nehemiah though. Yeah, Nehemiah. Yeah, if you don't like to call me fearfully ugly, you can call me by Nehemiah. I prefer the other one. All right. So, quick one. Please, if you haven't subscribed to this channel, kindly do that fast and quick. And also like this video so that anytime your friend comes on YouTube to search for a data analysis video using like paired samples and the like it will send him or her straight to this video. Yeah. So thank you very much. All right. So today we'll be continuing our session on data analysis, right? And today we'll be talking about paired samples. We're talking about how to use SPSS to um, construct hypotheses for paired samples, right? So let's quickly go through what. So basically, paired sample test is more or less like comparing a before and after situation, right? So there are some assumptions that we normally take whenever we are coming to do anything concerning hypothesis. Normally, using a paired sample, we assume that the paired values are normally distributed. Yeah, that's the assumption behind it. We assume that the pair values are normally distributed. So basically, the paired sample test is a test which is used to test the differences between population mean using two related paired matched before and after samples. So, like, I think just recently there was some challenge going on online, which was about when Esther wasn't having money, Esther was black, and when Esther saw money, Esther blushed. So they were trying to compare when Esther wasn't having money, her color, and when Esther got money, her color. So the difference between the color when she wasn't rich, and then after she became rich, that was what they were trying to compare. So that was why they were like, when Esther wasn't having money, Esther was black, but when Esther saw money, Esther blushed. So more or less like Esther bleached and the like. So basically, that is what we use this paired sample testing technique to do, right? So we used to compare some kind of variables before and after some particular period. So let's say initially you normally study when it's getting to ending of a semester, right? That's like we're last minute learner, right? And you normally would score, let's say BBB. But when you became a full-time learner, like from week 1 up to week 12 or week 13, now you are scoring 8, right? So the difference between when you were a last minute learner and when you became a full-time learner is like we're trying to know the difference. We're trying to test for the hypothesis whether you learning full-time really changed your grade or it didn't. That's what we are coming to test today. That's basically it. So it can also be more or less like let's say eating some particular food and the blood pressure of a body. Right? Let's say some people take too much sugar into their body, their blood pressure increases, right? And we want to test that claim. Or there's some claim outside that when people take in sugar, their blood pressure increases. So if we want to test that claim, then we can, let's say, like 10 people and then give them sugar. But before we give them sugar, we'll test for their blood pressure, right? And then after giving them the sugar, we test their blood pressure, right? So now that same kind of people, now that's the kind of people we are going to test this claim on. So before and after taking the sugar, their blood pressure is what we are going to use to test this claim, right? And then see whether if it is true or it is not true. Remember our old how we used to solve for the single and then the two test hypothesis, right? If p-value is less than the alpha, we reject the null hypothesis, right? And then if p-value is greater than the alpha, we fail to reject, right? So that's the same thing we are going to do in here. So kindly pay attention and let's do this quick, and let's do it. All right, so I'm sure today's video will be so brief. Yeah, I'm sure it will be brief. It will be very brief. All right, so paired or dependent sample test. It is used to test the differences between population mean using two related paired matched before and after samples, right? So population difference is the mu d, right? But since population difference is the mu d, mu here is going to be 0 because we are testing for the same kind of population, right? So mu d is going to be 0. Now let's go. Assumption: data or difference, which is the mu d between paired values, are normally distributed. So this is the formula for testing for the paired sample, right? And we are going to break each and everything here one by one, right? So remember that this is also a two-tailed test. So alpha is always divided by 2. Let's keep this in mind, right? Let me go just 2-3 steps away and then explain some stuff and come back to this formula. All right. So all right. So hypothesis testing for paired sample uses two-tailed test, right? So we divide alpha by 2. We divide alpha by 2. That's what we are seeing here. We divide alpha by 2. Okay. We use this one. So we divide alpha by 2. All right. So now this is a sample collected. This is what we are going to use for our example today. And this is what we are going to use. This is what we are going to use to test our hypothesis today, right? So this is an objective of study, which is to explore dominant fintech applications in Ghana. To investigate the adoption and usage of fintech applications in Ghana, we are trying to derive a hypothesis whether there is readiness in adoption or there is no readiness in adoption. So the null hypothesis becomes mu d is equal to 0, which means the null hypothesis becomes mu d is equal to 0, right? Which means there is no readiness in adoption. So when we solve, right, and we are accepting the null hypothesis, then it means that there is no readiness towards in adoption, right? And then HA, the alternative hypothesis is saying that mu d is not equal to 0. So when we test and we are rejecting the null hypothesis, then it means that there is no readiness to adoption. So when we test and we fail to reject the null hypothesis, then there is no readiness in adoption. But when we test and then we reject the null hypothesis, right, then it means that there is readiness in adoption of the fintech applications, right? All right, so research approach, we use both mixed approach and then we use mixed approach, which is quantitative and qualitative approach, right? And then sampling sizes and sampling techniques are also used. We also use convenience sampling, and also the sample size used in this is 21, right? So let's do that. Right. So this is the data we have here, right? To test for our per sample hypothesis today. This is what we are going to do. So to do this, kindly open for less difficulty. Let's kindly open our Excel. Open your Excel. I'll start everything from a new. Open your Excel and also open your SPSS, right? Open your or launch your SPSS. Let's start this, right? All right. So now let's copy this from the slides and then paste it in our Excel. So you can just click on it and then right click. Sorry, click on it and then right click and then come and click on copy. Or you can also press Ctrl+C on your keyboard, right? You can do that. Then come to Excel, just the first line here. Come and paste either Ctrl+D or you right click and then you click on paste here. Everything is in here, right? So every info which was down there is now in here. All right. So now let's quickly go to our SPSS and code these infos there. Let's code them. As usual, you can do it fast. So let's come to our SPSS, come to variable view, and let's code. The first part is gender. So gender, type of gender is categorical. So for categorical, we choose string or string, any of them. Okay. Then now we come to label. Label, we can write either indicate your gender or gender type. All right. So now we assign values to them, which is we either make one to become female or male, any of them. So let's use one to be female. Then let's use one to be male. So one to male. Then we add, then two to female. Then we add. Press OK. Right now we leave everything here. Gender is a nominal data, so we leave it as nominal. Right. Then now the next part is fintech application type. So fintech. The next one is type of fintech application. So you can type everything or fintech type, any of them. So fintech. Then because here you cannot bring space, this is at the name side, you cannot bring space. So bring underscore, which can be shift and then the key, which is the first right of 0 on the keyboard, will get underscore for you. For my PC to get underscore for me, I don't know about yours. So then I type fintech type. Then this is also categorical. This is also a categorical data. Then I put the strings here again. Then type of fintech app. values and choose any of them. So 1. So they are basically 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4. There are basically 5 applications in here. So let me assign values to them. As here, I'll come in and assign the same thing to them. So 1 is going to be Momo, 2 is going to be ZP, 3 is going to be Haftel. Let me do that. So 1 is Momo, 2 is going to be ZP, 3 is going to be Haftel, 4 is going to be Slide P, 5 is going to be Express P. Right. This is still a nominal type of data, so let's leave it like that. And then let's check here. All right, so have the Express P, Slide P, and everything has been injected. Right now, we are coming to also code for the pre-rating and then the post-rating, right? So pre_rating. This is a numeric. This is numeric. Leave it at numeric. And then maybe change it to scale. And then post. _rating. You leave it also the same thing, I guess. Right now we are seeing everything in here. Whatever recorded is in here now. So let's check the same thing and then filter out our destiny in Excel. So filter, you just right and click on gender. Just click on gender. Come to home. Insert. All right, so you click on gender, you come to data, you see filter here. Then you see that this arrow has appeared here. Click on this, untick all, and then leave only email. Press OK. Then 1 for mail, right? So that's what we did. 1 for mail. Either you click, when you see this sign, the black cross here, it's either you double click on it or you click and drag. So click and drag down. Everything changes. Now come here again. Come and select female. And then type 2 in here. And click and drag. All right, so you change everything. So now you can select all. All right, everything is in here. So here too, remember we changed almost everything in here. So Momo was 1. So on select all, then select only Momo. Then put 1 in there. Click and drag. Then I'll come and select use ZP. Let me see whether 2 was ZP. All right, so 2 was ZP. So ZP capital selected. So 2 have cell, then 4 is slightly then 5 is express stage. All right, let's select everything. It's 5 express stage. Okay, that's correct. So now we will export our data. What's going on here? Why is some of the figures missing? Wow, some of the figures are coming. All right, well, let me put it in there. So why did some got missing? Wow. All right, so let me start again. I'm just trying to keep everything. So it's just the same process I'm following. Now some is missing here again. It is a moment. All right, I think everything is intact. Yes, let me see the data. All right, yeah, the first one is moving. All right. All right, so now what we are coming to this, we are coming to export it to SPSS. So click, highlight all, then Control plus C. Or you can right click and then click on copy. Come to the SPSS data view. Just tap on the first listing and agenda, then Control plus V. So everything has changed. Remember, the reason why you are seeing 7.0, 6.0, and everything here is that we left it in two decimal places. So let's change it to 1 and 0, 0. So everything is soon bouncing. So when we click here, it will change to the numbers. Then now it will change. So now we have our data in here. So now let's run our paired sample statistics test. Right? So we'll come to analyze. Okay, now it's okay. We have our data here. Let me go and talk about it before we come. So now let's come back to this. Let's come back to this. So what we are going to do in here now, this here is basically C, the formula for the paired sample C test is C is equal to B bar minus mu D all over standard deviation all over root n. Note that this basically means that C is equal to the mean difference. C is equal to the mean difference over the standard error. So what you are seeing down here, the denominator here, is the standard error. Right? So this is the standard error. This is the standard error. Right? And this is the mean difference. The mean difference for C test is normally B bar, right? Because the mean D is 0. We assume it to be 0, right? And then now, before we solve for SD, we also have to do this summation of DI minus D bar. So now, let's first solve for D bar, and then we'll do everything in here, right? So, let's go on Excel. What I'm going to do is I'll do, let's say, 1 or 2, then we can continue the rest. So to make things faster and shorter, I think have this here. Same thing in here. The same information. I computed the DI. The DI is basically the post rating minus the pre-rating. So here 6 minus 7 giving us -1. 5 minus 6 is giving us -1. 5 minus 4 is giving us -1. So that's it. For DI is equal to the post rating minus the pre-rating, right? So after Esther bleached minus when she wasn't bleaching, that's basically what it means, right? So this will run up to the last, and so you can just equal to D2 minus C2, right? Which is D2 minus C2. When you're done, you can just drag it up to the last one. Everything will be solved automatically for you. Or you can double click when you see this black cross sign, and then everything will be calculated for you, right? So now we have DI in here. So DI divided by the sample size is going to give us D bar, right? So DI, let me write this. So summation DI all over the sample size is going to give us the D bar. So all the differences that we had in here, by subtracting the post rating from the pre-rating from the post rating, which is post rating minus pre-rating, all of this thing we had, when we summed them, we had -16, right? We had -16. Then our D bar is equal to -16 divided by 21, because the sample size is 21, right? So basically what it means in here is that it is going to be -16 all over 21. That's what we did, and we had -0.7619. Mind you that according to Dr. Abeku, we are only taking the absolute when we are dealing with the mean. When we are told to compute the mean in exams, let's only take the absolute figure. But in solving for our t-test, we are going to use the negative, right? But okay, no, we are not going to use the negative. We are not going to use the negative. But in solving for the standard deviation, where we'll be using D bar there, for that one we are going to maintain the negative. But for solving for the t-test, for the mean, we are not going to use. We are going to use the absolute figure instead. So now let's try and then do this. let's run everything. Then after that, remember the formula is equal to d bar minus mu d all over s d over root of n, right? Where SD is the standard deviation. Root of n is the root of the sample size. The d bar here is the di's divided by d bar is equal to summation di all over n, right? And then SD, right? SD, now let's talk about SD, standard deviation. Standard deviation is going to be the root of the summation of into bracket di minus d bar all squared all over n minus 1, right? So that's what I've done here. I've done the same thing here. So what I did was, now so what I did was, what I did was on Excel, di minus d bar, which is, we had d bar to be negative 7, sorry. Okay, so d bar was 0, a negative 0.7619 or so, right? And then here is going to be d bar, sorry, di minus d bar. So more or less like equal to this minus this. You see we are getting negative 0.2381. That's the same thing here. That's the same thing here. Here is 1, right? So 1, sorry, equal to 1 minus this. You see, that's what we are getting here. So that's it. That's what's happening here. So I just did for the first one, then I logged it by using $24 because I saw for the D bar in row 24, which is here, D bar is here in row 24. So I logged it. I logged it by using the $sign, and then I just dragged everything. So I logged it here, as you can see, E2 minus $24. So 24 has been logged. And then I just dragged everything, and then it went all the way down. So that's the same thing I'm going to do, right? Do the same thing. Do the same thing for it, right? And then drag everything to the downside. But remember that in the formula, this was how it was. This was how it was. It was the root of the summation of d I minus d r squared all over n minus 1. So meaning that we are going to square all these differences and sum them. So now after getting all this d and bar, we are going to what? So I'm not sure we'll be giving this an example, but I'm just explaining. We are going to sum all of them and then square them, right? Sum and square them. So this one squared plus this one squared plus this one squared. So it is more or less like 0 negative 0.2381 squared plus the same thing, negative 0. Okay, so negative 0.2381 squared plus the next one is into bracket 1.7619 squared, as it follows, like that and like that and like that. Right, that's the same thing we are going to do here. So, but in Excel, it is very simple. In Excel, what we are going to do is you are going to just, if let's say I want to find the sum of squares equal to sum of squares. So you see sum SQ here, double click, and come and select you want it to be sum and squared. You click, it starts dragging from the first part up to the last part of it. Then press enter. Here is it. It has solved it for me. 129.81. So this 129.81 is the summation DI, is what we had at the top side of the numerator of this. So summation DI minus D bar squared is what we've gotten as this. Right, so now we are having 129.81 all over n minus 1. So 21 minus 1 is 20, because n is 21. And so when we do this, that's when we are going to get standard deviation. That's when we are going to get the standard deviation. Right. So now this will be equal to, we are just doing everything here before we start so that it will be easier for us. So now this is going to be equal to square root. So I'm just putting everything in Excel. So it is equal to the SQRT, the square, sorry, my bad. So this, right, you can take this divided by 20, right? That's it. So this whole thing here, this formula thing here, this is what I've entered in Excel. Press enter. Sorry, had 2.54.76 as SD. So SD is equal to 2.54.76. Okay, I had a different SD here. But this is what it's supposed to be. 2.54.764. Yeah, we are going to get this. This is going to be our SD, right? And then root of n. If we divide this by root of n, if it's equal to this divided by SQRT square root of n is into 1. This is what we are going to get as our standard error. SCD. This is what we are going to get as our standard error. Remember, we said that the standard error remember we said Yeah, the standard error is equal to the root of n. Sorry, standard deviation over root of n, right? So standard error is equal to SD over root of n, right? So when SD is this, and then root of n is equal to root of 20, 21, sorry, root of 21, right? So that's when we get this as our standard error, right? So now we solve for our mean difference and then get here. Now let's move to the SPSS and then do this faster. All right, so we come to analyze, we come to our SPSS after uploading our data and everything. We come to analyze, and we come to compare means. Compare means we are seeing, we skip everything, we come to the paired sample t-test. Click on it. Right. All right, so let me learn. All right, so we click on it, then you click on it, then you first click on the pre-rating, then click here to drag it there. You come to post-rating, click here to drag it there. So pre-rating is here, post-rating is here. Now when we come to option, we are seeing our confidence interval, which means we are 95% confident that this is true. So the room for error is the 5%. For alpha. Alpha is going to be 5% in here. Continue. I click on OK. All right, so we get everything in here. So here, what is most important to us here is paired sample statistics and paired sample test. That's what is important in here according to our exams, right? So what we are going to do now, we look at Dr. Abeku said you can choose to clean out n. You can choose to clean out this n and then tell you to compute for n, right? If you want to compute for n, remember if degree of freedom is here and it's 20, remember degree of freedom for two sample tests is 40, n minus 1, right? But if n here is 21 and degree of freedom here is 20, then when you add 1 to the degree of freedom, you are going to get n. So it's going to be 21 in here, right? And then now let's come here. Remember our mean. We computed our mean to be negative 0.762 in here. It's negative 7.619, right? Let's change it to 2 decimal places because Abeku said in the exams we are going to leave everything in 2 decimal places. Let me change it to 2 decimal places here. So it's going to be 0.76, right? That's what we are getting here. 0.76. I think we don't really want us to get it in a cheaper way because subtracting these means, pre-rating mean from post-rating mean, you are going to get this 0.76. But because he doesn't want us to get it this easy, he said that this is not going to be true or correct. But I've tried other stuff and then it was still giving me the same correct answers. So I think subtracting the pre-rating mean, subtracting the post-rating mean from the pre-rating mean, you are going to get it. Right, you are going to get it. All right. So now let's move on. Standard deviation is SD. We've gone through that one here. You can replay the video and then watch that one. The summation of DI. DI is the difference minus the D bar. We computed the D bar is the difference summation of the difference all over the sample size, right? That's what we had, the D bar here. So that's it there. And then now, the standard error, we've spoken about it, that the standard error is equal to S D all over root of N. We said this already. That's the standard error, right? That's the standard error. And then the D bar, remember we had D bar to be equal to 0.762, right? So now our T test is going to be, remember, now our T test is going to be, let me write it. Remember, I want to do this faster. Remember, our T test is equal to B bar all over S, the standard deviation over root of N, right? And then now, B bar is 0.762 all over SD is going to be 2.58. But remember that I told you that the denominator is for standard error. So you can just simply put the standard error here, 0.556. Right? And you are going to get a T of 1.370. This is this. Right? Degree of freedom is equal to N minus 1. And then standard error we've computed, standard deviation we've computed, but for two tail we will hardly be told to compute for standard deviation. Mean here has been computed. Degree of freedom 1 is here. So N here is 21 minus 1 is equal to 20. Oh, sorry, I get it in here. Then this is what when you trace on the T table, which we will not really deal with that, so it is not very important here now. So let's try this in here. Right, we had this to be a standard error, and then our difference is, so T is equal to our T test will be equal to the mean difference divided by, or the mean divided by the standard error here. Then this is what we are getting. Remember, it's going to be an absolute figure, because on the T table, we can't get an absolute, we can't get a negative. So 1.37047, let's check in here. How did we get 1.37? So you see the same thing. We've worked like the machine. You get it? So that is it up to this point. Now let's talk about the p-value. Remember our normal formula that we use for either rejecting or accepting the null hypothesis, right? And here, p-value is 0.186, and alpha is 0.05, right? But since it is a two-tailed test, we are going to divide alpha by 2. So we are going to get 0.025, right? And we are going to compare this to the p-value. Right? Since this is a two-tailed test, we are going to do that. Remember, if p-value is less than alpha, we reject each row. And when p-value is greater than alpha, we fail to reject state 2. Right, so this is alpha. Alpha is equal to 0.025, and then p-value is equal to 1.8. Sorry, it's equal to 0.186. So p-value is 0.186. Alpha is equal to 0.025. What are we seeing in here? We can see that p-value is greater than alpha, right? Therefore, we fail to reject the null hypothesis that there is a readiness to come. So basically, what we are going to do now is, since we are rejecting the null hypothesis, right? Sorry. All right. So now, let me take this again. I'm not confused though. But alpha is less than p-value, meaning that p-value is greater than alpha. So we fail to reject the null hypothesis, right? So our conclusion is that we fail to reject a null hypothesis as there is no readiness for adoption of the fintech application, because the null hypothesis is that let's check this, is that there is readiness for adoption, right? The null hypothesis is saying there is no readiness for adoption. So meaning if we are failing to reject the null hypothesis, then it means that what the null hypothesis is saying is true. There is no readiness in adoption of the fintech applications. That's why we are failing to reject it. But if we were to be rejecting the null hypothesis, then it means that there is readiness in adoption, right, of the fintech applications. That's what we have in here. So basically, that's it for paired sample t-test statistics, right? So we'll close here and then meet some other time for the correlation and regression, right? So as you are seeing here in Excel, I saw for D bar, then I saw for DI minus D bar, which was in the SD, which was the summation of DI minus D bar, right? And now DI minus D bar squared. I just did it one by one so I squared them. So in squaring, you can choose equal to this DI minus D bar. Then you press shift. For my keyboard, when you press shift and then 6, it will bring this sign, which means you are squaring. So when you bring 2 here, it means you are squaring. So enter, you're getting the square of this. That's what I have in here, right? So that's it. I hope you really enjoyed this. Don't forget to like and subscribe to this channel. And then, if you still don't understand anything or there's anything you don't understand, you can see me at school, then I clarify everything for you. All right. See you some other time. Take care. Goodbye.